Okay, I'm going to give you a little lesson over Module 8, which has a lot to do with exponents, and I'm going to teach you several rules of exponents that I think are really important. But before that, let's review what an exponent is for just a moment. If I have 4 to the third power, 4 is called the base, while 3 is called the exponent. Alright, I know you know this, but this is important terminology. So 4 is the normal size number that's being taken to a power. 3 is the superscript, little floaty number above. That refers to the power we're going to, and the name for that is an exponent. So what does that mean? Well, we know it basically means this: 4 times 4 times 4. The operation's multiplication. We write it down 3 times because that was our exponent. And if we do the math, 4 times 4 is 16. Times 4 would come out to 64. So when we have a number, we can go ahead and answer it if we want to. All right, so that's a quick review of the term base and the term exponent. So now let's get into some rules. Rule 1, real simple. Anything to the first power is just itself. X to the first is x. 5 to the first is 5. And why is this? Because it's telling me to take the number or the variable and write it down that many times. And the operation would be multiplication, but there's nothing else there to write. So it's just that variable. And it goes both ways. If you ever see a variable sitting by itself, you know it's understood to be the first power. That's a real easy rule to understand, but a really important rule as we go forward. So first rule of exponents: anything to the first power is itself. So we'll write these generically. I'm going to give you some notes, but this is the video to kind of support that. And this is all from Module 8. Kind of a combination of several sections. But here we go. First generic rule: anything to the first power is itself. So we'll call it a to the first equals a. Easy enough. Let's talk about rule 2. This one's a weird one. You may have encountered it in another class. But anything, we'll start with a number. Anything, number or variable, anything taken to the 0 power is actually 1. So 3 to the 0 is a 1. X to the 0 is 1. 5,625 to the 0 power is 1. Intuitively, it doesn't make a whole lot of sense because you're telling me to write something down 0 times and it come out to be 1. But you'll see in a little bit why this rule has to exist. So for now, we'll call it rule 2. Any base taken to the 0 power comes out to be the number 1. So 2 rules so far. Anything to the first power is itself. Anything to the 0 power is 1. And now let's get into some stuff that actually kind of fun, some shortcut rules that allow you to do some problems really quickly. Rule 3. Let's say you had a problem like x to the 5th times x to the 3rd. Now all of these rules are really going to involve the same base. So you can't use this rule for like x times y or 3 times 2, but since this is x to the 5th times x to the 3rd, you might be real tempted to write x to the 15th, but you'd be wrong because the answer is just x to the, some of you know this, 8th power. So it makes sense why this is if you break it down. What is x to the 5th? X to the 5th is, slide that over. I'll just rewrite it. X to the 5th is this. Okay? And then you're going to multiply that by x to the 3rd, which is this. Well, all you've done is put a long strand of x's together. How many do you have? 1, 2, 3, 4, 5, 6, 7, 8. Okay? So that means you can use that on numbers as well. If someone gave you 2 to the 3rd times 2 to the 4th, you know that it's 2 to the 7th. And you could actually compute that number if you needed to. I think that particular one would be, don't have my calculator right now, but I think it's 128. But the point is you can use the rule to shortcut things. So what is the rule? If you have a base to some power that we'll call m, multiplied by that same base to some other power called n, then the shortcut way of solving that problem is to add those exponents. Keep that base, but add those exponents. So one more time just to see it in action. And it's really nice for a problem like this. If I give you y to the 31st times y to the 30th, do you really want to start writing a bunch of y's and trying to figure this out? Nope. You want to take the rule, which is keep the base, add the exponents. Really quickly, you've got the answer of y to the 61st. Okie doke. So, what's rule 1? Rule 1 says anything to the first power is itself. So we used the generic letter A minute ago. What's rule 2? Anything to the 0 power has to come out to be 1. And that's still a weird one, but we're going to see why later on. And now we've got rule number 3, which says if you've got a to the m times a to the n, the shortcut is add those exponents up and get a to the m plus n. All right. Rule number 4 kind of goes in companion with rule 3. It goes like this. Let's say you had something like x squared in parentheses being raised up to the 5th power. Now, the answer, let's think about it. What does x squared to the 5th power really mean? It means you should have 5 of those x squareds. So 1, 2, 3, 4, 5. Well, if you've got 5 of those and you use the rule we just learned, add, 2, 4, 6, 8, 10. Well, what's the shortcut of that? Some of you probably figured it out. You can just multiply. So, rule 4, if you have some base raised to a power, raised to another power, the shortcut rule is to keep that base and multiply those exponents. Let's see that in action a few more times. Let's do a number. Switch colors here for a minute. So we had 5 squared raised to the 3rd power. Well, one route would be to actually do the math here and get 25. To the 3rd power, which again we could put in our calculator and get the answer. But we can quickly at least go here. 5 to the 6th. Because all we're doing is taking the product of those two exponents. So it's really useful with variables. Let's have y to the 7th raised to the 2nd. Answer, y to the 14th. And the reason again is if you take y to the 7th 2 times, what would you do according to rule 3? You would have added those anyway. So this saves you time. All right, so we've got rule 1, anything to the 1st power is itself. Rule 2, anything to the 0 power is 1. Rule 3, if you're multiplying things with the same base, you can add those exponents. Rule 4, if you're raising a power up to another power, you can multiply those exponents. How about rule 5? Rule 5, let's go to our division rule. If you have two bases that are the same, and again, these rules don't work if the bases are not the same, but if you have two bases that are the same, x to the 6th divided by x to the 3rd, you might be tempted to say x to the 2nd, but you'd be wrong because the answer is x to the 3rd. Now let's see that in action. What is x to the 6th? Well, it's 6 of these guys. What is x to the 3rd? Well, it's 3 of those guys. If you understand division, you got one on top, one on bottom. They're the same. What can you do? Cancel, cancel, cancel until you're left with how many? Well, x times x we know is, by definition, x to the 3rd. So instead of us having to do all that work, the shortcut, if you have two like bases, same bases, different powers, and you want to simplify that, keep that base, subtract those exponents. So when dividing, the shortcut is to subtract the exponents, which makes sense because when you were multiplying, what was the shortcut? It was to add those exponents. Can this work with numbers? As long as it's the same base, 10 to the 8th divided by 10 to the 3rd, you guessed it, 10 to the 5th. And since it's a number, if you wanted to go further, 10 to the 5th, I believe, is let's see, you'd get 100, 1,000, 10,000, and then 10,000 times 10, like 100,000. So if it's a number, you could go ahead and go all the way to that answer if you wanted to. All right, 5 rules so far. Rule 6. And this is kind of what I call a chain rule. If you've got some extra variables going on, as long as you use the previous rules we've taught on the things that are the same.